All right, guys, welcome to lesson number 2, real numbers. Bum, bum, bum. Okay, so this picture does not look as nice and neat. So what I'm going to do is I'm going to shrink this down a little bit so we can see the whole thing. So you're going to want to copy this into your notebook. Oh my gosh, that's pretty fairly there. Okay, a little bit more. Sometimes it's always hard to tell how it's going to display once I've written it. So you're going to want to go ahead and copy this down and then we'll talk about it. So pause that video and copy down this picture. Okay, guys, so we are going to explain real numbers. So real numbers conclude of all of the things that you see labeled here. And in my opinion, it's easier to show examples of these than to just give you the word definition. Honestly, it's such a complicated concept, but super simple the moment that I give you an example. So a natural number is anything that can be found in nature. For example, I can hold one pop can. I could hold a case of pop cans. I could have one pen. You know, some things that you can actually hold. So this can be any numbers like 1, 20, 7, anything you can actually physically, tangibly hold. Next, we'll go into a whole number. Whole numbers are natural numbers, but they also include the number 0. Now, you're probably asking, but wait a minute, whole numbers should include, natural numbers should include the number 0 because I know I can have none of something. Well, yes, you can have no pop, you can have no pencils, you can have no something, but you can't physically see the number 0 of them. You just don't have any. So 0 is more of a concept than an actual being able to physically see that number. So it's a weird thing to think about, but no, you can't physically see 0 amount of something. You just have none of it. Next, we move into integers, and those include whole numbers and natural numbers. They also include things like -7 and -10. So we start adding those negatives into it, and my zeros are terrible on this thing. They always kind of look like 6s. Next, we go out to rational numbers, and we've seen rational numbers before. That's things like a half and say 75%. And decimals like 0.45 and repeating decimals like 0.4. So that's one kind of 75% of my real numbers. The other 25% of my real numbers are what's called irrational numbers. And those are numbers I can't simplify. So like the square root of 3, our favorite number pi, and just something that continues to go on and on and on forever without end. Square root of 7. Oops, that's a really terrible square root sign. Something that just does not simplify. All right, we're going to go ahead and classify these following numbers, and we're going to classify them based on what was above. So we have the fraction of 5 over 22, and since that itself is a fraction, it is at least a rational number. Again, I'm going to type because my handwriting is horrific. But if I go back and look at that picture, I know that I can't simplify 5 over 22. Let me go back for a moment. No, go back. I can't make that into an integer. It just isn't going to happen. It's not going to be something that I see in the number line. So that's as far as I can go, as this is a rational number. The next example is the square root of 81, but we know the square root of 81 is also equal to the number 9. So because even though you think he should be in this irrational number category because he's a square root, he's still equal to that number 9. And number 9 is something that I can tangibly see in nature. So this is a natural number. It's a whole number. I need to scroll down. It is an integer. It is a rational number. So it kind of falls under all of my categories on that left-hand side. I'm going to capitalize it because I like to be consistent. And then my last one, square root of 56. Well, if I grab out my handy-dandy calculator, because off the top of my head, I don't believe it can reduce down. And when I go ahead and actually take that square root, oops, I accidentally hit a button. I see that I do not get a whole number, so it does not simplify. So he is just simply a irrational number. I can't turn that into a fraction of some sort. I can't try and get that guy to stop repeating over and over and over again and reach that point of stop. All right. Now we're going to learn how to write a repeating decimal as a fraction. These are definitely a little bit trickier, I will give you that, but make sure that you're trying the best that you can to work these through and understand them. They're not an easy concept. That's all I can say. Just happens sometimes, guys. So what we're going to do first is we're going to pick our favorite letter. And my favorite letter is going to be N. I'm going to try and type these small off to the side as well, so you can see them as we're going. So let's do, actually, we'll do 12. I think that might make this the best. And I'm going to do it in blue because I need some color for my explanation. So why not? So first, pick favorite letter. I don't need to capitalize this. I, for some reason, always feel the need to capitalize everything. And I'm going to put what I did in parentheses next to it. So I'm going to pick the favorite letter N. And I'm going to let that N, and I need to do this a little bit nicer, be equal to my, back up. So I pick my favorite letter, and then I need to pick favorite number 1 to 5. I'm going to pick 4. Now, that 4 stands for how many variations of my repeating digit. Now, a digit is a single number, so in this case, my digit here is 7. And since the only number that I'm repeating, or the only digit that I'm repeating is 7, I'm going to say 0. Ah, man, my zeros are terrible in here. 7, 7, 7, 7. So that's where that 4 comes from. I'm going to use that as my repeating guy 7 times. 4 times. So I'm going to repeat that repeating guy of the 7 4 times. My next step will be to multiply by a multiple of 10. And this will be based on how many repeating digits I had. Now, since I only had the repeating digit of 7, as one single number, I'm going to only multiply by 10. This will increase to 100, 1,000, 10,000, 100,000 based on the amount of repeating digits. Again, I only had one repeating digit, the 7, so I'm only going to multiply by 10. And what I do to one side, I do to both sides. Well, let's not use blue to confuse ourselves. There we go, scroll down a little bit. So this leaves me with 10 times something. Remember, my favorite letter will stand for something. So 10 times something is still just 10 times that thing. It's a little rough N. Multiplying by 10 to the black part will cause the decimal place to move over 1. So 7.1, 2, 3, 4. Again, we want to keep that. Sorry, I didn't do that very straight. 1, 2, 3, 4. Okay. I want to continue having the same amount of decimal spots because the idea is to get a fraction. And with fractions, we don't ever have decimals, and it's setting me up for my next step here. Next, I'm going to show my subtraction, and we're going to subtract the original equation that I wrote. And in this case, that equation is black, and this is kind of like why I like my smartboard sometimes. I'm going to do this. And I am going to take this guy and move him down below and try and line him up. I don't always write the same size. I'm going to actually I'm going to take away 1 from each side. So my next step will be actually subtract. So I'm going to show my subtraction here with my purple color. And I'm going to actually do that subtraction. Now, follow the mouse for a second, because I can't get my finger to magically show up on the board, which I think would be cool. So just follow that pointer. So I'm going to take 10 of my something, in this case my favorite letter N, minus 1 of the something, because there's just 1 there. So do I need to indicate it with a 1? No. Can I? Yeah, but I'm not going to. So I have 10 of my something minus 1 of my something. It will give me 9 of my somethings. Those N's are just killing me today. And then this is the cool part that I like. This guy crosses off, this guy crosses off, that guy crosses off, that guy crosses off. So I'm getting rid of all of those decimal points, which is why I subtract by my original, so that I can cause them to go bye-bye. And then I have 7 minus 0, which is just 7. And then my next step will be to divide by the number with my fave letter. And then I have 1 more step after that. And I wanted to put that there so I didn't forget. And I need a little bit more space. Oh no, undo that. Ooh, excuse me. I need a little bit more space so I can scroll down. So I'm bringing my directions with me. So I'm going to show my division. And I'm dividing by the 9, because my favorite letter in this case is my N. And I know 9 divided by 9 will cause that to go to 1. And 1 times something is just itself. So I get the number, or the letter N. And then 7 divided by 9 cannot simplify anymore. And that last step was going to be, should have let me stop again, stop moving, simplify if needed. Again, 7 divided by 9 can't simplify, so therefore I'll just leave it. And then the idea here is to write that repeating decimal as a fraction, and I have a fraction now. I have the fraction of 7 over 9. And I'm going to scroll back up for a moment, because we were asked to write it that repeating decimal in fractional form. And if you notice, when I take 7 divided by 9, I get my repeating decimal of 0.777777. And then my calculator rounds my last digits for me, which is why you see that 8 at the end. But that's essentially that decimal in fractional form. So we checked it with our calculator. Okay, we're going to do the exact same thing. So what I'm going to do real quick is I'm going to copy my directions, and then I'll change the parts that we changed as we go. So we can see on my whiteboard, I kept these off to the side. Sorry, kept them up off to the side for you guys. Since I can't really do that when I switch slides, I just want to repeat it. And I kind of want to switch some of these up. So I'm gonna, oops, no, stop. That's not what I asked you to do. I'm going to delete my quote unquote favorite things that I changed or used last time. Oh no, where'd it go? Undo, undo. I'm just trying to delete this part. I don't know why that's so complicated today for my computer. I blame the rain because it's currently raining. Step number 1 is pick a favorite letter. I think I'm going to go with the letter, something that I can easily do. I am going to go with the letter, let's go with P. Why not? So I'm going to pick a favorite letter, and my favorite letter today is P. And then I'm going to pick a favorite number between 1 and 5, And I think I'm going to switch it up and go with 3. And 3 is going to be the amount of times that I write my repeating part. And since now I have 2 digits, I've got the 2 and the 3, I am going to write that 3 times as per my favorite number. So I have 0.23, 23, 23. So I've written it 3 times now. Okay, so I've got that part, I've got that part. Multiplied by a multiple of 10. Now in the last example, so I'm going to go back for a moment, I multiplied by 10 because I only had that one repeating digit. However, I have a 2 and a 3, so now I have 2 repeating digits. So instead of multiplying by 10, I'm going to multiply by, oops, that was the wrong number, 100. And what I do to one side, I do to both. Man, those are looking like 6s every day. So I'm going to actually go ahead and do that multiplication. So 100 times p is just 100p. 100 times anything is just 100 of that. Since I don't know what it is, I'm just going to kind of go with it. Multiplying this by 100 causes both digits to move over. So I'll have 23.23, 23, 23. Remember, I want to keep my original number there, because the idea next is to subtract. So I'm going to move him down, maybe, if it'll let me. It's being very finicky today, and I don't know why. Hey, I'm almost lined up this one. I'm going to show that subtraction, so I need to get my marker back out and say minus and minus. So I'm showing my subtraction. Now I'm going to actually subtract. So 100 minus something is simply just 99 of whatever that something is, and in this case, my favorite letter P. My equal sign comes down. And I'm not very good at writing today. Usually it's because my nails are too long, but that's not an issue. And then all of my decimal points cross off, which is pretty cool. And then I have 23 minus 0, which is 23. Next, I'm going to divide by the number with my favorite letter. Ah, I wrote P twice there. Oops. All right. My apologies. Sometimes I have errors too. 99 P's. P sound good. So I'm going to divide both sides by 99. 99 divided by 99 will simply leave me with 1 times my favorite letter, and that favorite letter in this time is B. And then I'm left with 23 over 99, and then it asks me to simplify if necessary. I don't believe anything can go into 99 and 23. So then what I'm going to do is check the calculator. Woohoo! Look at that. Same number I started with. So we did it correctly. Oh yeah. Gotta love this. All right, simplifying square roots. So we know that a square number is the same number twice. So for example, say I take 1 times 1, that's 1. Okay, woohoo, no, not too spectacular. What about 2 times 2? Well, 2 times 2 is 4. So 4 is my example of a perfect square. It's the same number twice. I also have 9, because that's 3 times 3. 16, and 25, and 36, and 49, and 68, or 64, excuse me. I know my numbers. So simply, I'm just going backwards then. And I like my example of 4 here, because if you notice, I have a 4 on top. So what number twice gave me 4? Well, it's just 2. So the square root of 4 is 2. And then I'm asked to find the square root of 121. And this guy is 11. Now, that's not my final answer, because I know I could have positive variations of 2 times 11. And I can also have -2 times -2 over 11 times 11, and so on and so forth. So because of this, my answer here is plus or minus 2 over 11, because I can have it positive or I can have it negative. -49 over 256. Well, the square root of 49 is 7. The square root of 256 is 16. And since it starts negative, my answer will be negative. There will be no plus or minus in this case. Estimating the square root. So what we're going to do is we're going to find the closest perfect squares. So I know the square root of, the square root of 9 is perfect. And then I have my 15. And then 3 times 3 is 9, so 4 times 4 is 16. And that would be my next highest. So I'm going to find the square root to the one lowest and the one highest, and then kind of see which one it's closer to. Well, we kind of agree that 15 is pretty close to 16. Excuse me. And the square root of 16 is 4. So the square root of 15 is about 4. So I want you to pause and try this next one. Square root of 130. And you should get about 11. All right, that's all I have for you. Have a great day.